Chapter 5, Section 6, Data Discretization. Have you ever struggled to make sense of messy data, like hundreds of values? What if you could simplify all that into clear, easy-to-analyze categories? That's exactly what we will learn in this section, a technique called discretization. It helps turn continuous numbers into meaningful categories, making your analysis sharper, clearer, and easier to communicate. Let's dive in and see how it works and when to use each method effectively. In one sentence, this section will see how to simplify continuous data with equal width and equal frequency binning. Discretization is the process of converting continuous numerical values into discrete categories or bins. Instead of treating variables and continuous numbers, we group them into intervals to simplify complex data, improve interpretability of the findings, and make categorical models more effective. For example, rather than using raw years of experience, we can categorize employees as junior, mid-level, and senior. This transformation enables HR teams to analyze career progression patterns rather than dealing with exact numbers. There are two primary methods for discretization. Equal width binning. It divides data into equal size intervals. Equal frequency binning. It distributes data so that each bin has approximately the same number of data points. Let's explore how each works. Let's explore the details of equal width binning. Equal width binning divides the range of values into bins of the same size. As an example, let's see a dataset of employee working hours. Using equal width binning, we categorize employee working hours. If we apply equal width binning with 3 bins, we might get this result. Now, we can classify employees into low, medium, and high working hours. Let's go on to another type, equal frequency binning. Equal frequency binning ensures that each bin contains roughly the same number of observations. As an example, let's discretize employee salaries. We have 9 employees with salaries. Using equal frequency binning with 3 bins, we ensure each bin has 3 employees. Now, let's implement equal width binning using Python. Let's use this dataset that records each employee's monthly working hours. Using Python, we will apply equal width binning and obtain this result. First, import pandas and NumPy. Pandas is used for handling data in table format. NumPy is not strictly needed in this case, but often useful for numerical operations. In the next code block, we create a dataset by creating a Python dictionary containing a list of employee names and a list of their corresponding monthly working hours. Then convert this dataset into a data frame by using pandas dataframe method. Let's go on. This line specifies that we want to divide the data into 3 equal width bins, low, medium, and high. The next part creates equal width bins. Ph.D. cut function slices continuous numeric data into intervals. Next, insert the column we are binning. set the argument bins to num_bins so that it tells cut function to divide a range into 3 equal width intervals. The next line assigns a readable label to each bin. Set the argument labels with a list of labels. The last argument, include the lowest, is set to true so that it ensures the lowest value is included in the first bin. By running this code, we can add a new column named category to the data frame. It shows whether each employee's hours fall into the low, medium, or high bin. Next, let's implement equal frequency binning by Python. Let's use this dataset that records each employee's salary. Using Python, we will apply equal frequency binning and obtain this result. First, import pandas. In the next code block, we create a dataset by creating a Python dictionary containing 2 keys. Employee is a list of employee names. Salary is a list of their respective salaries. Then, convert this dataset into a data frame by using pandas dataframe method. Let's go on. First, set the number of bins we want to divide the salaries into. In this case, 3 categories: low, medium, and high. Let's go on to the next block. Pandas qcut function performs equal frequency binning. Next, specify the column to bin, salary. The next argument, q, is set to num_bins so that it splits the data into 3 bins with approximately equal number of records in each. Finally, the argument labels with a list of names assigned to each bin: low, medium, and high. The result is stored in a new column, category, in the data frame. The category column that shows whether each employees fall into the low, medium, or high salary group based on equal frequency binning. We need to choose the right discretization method depending on the cases. Equal width binning is simple and easy to interpret, but it may result in uneven bin sizes if data is skewed. Equal frequency binning can balance categories, preventing uneven distributions. However, in equal frequency binning, bin width may vary, making comparisons harder. Therefore, equal width binning is appropriate when data has a uniform spread, that is, evenly distributed. When data is skewed, equal frequency binning is better in many cases. Let's wrap up. Discretization converts continuous variables into categories. Equal width binning divides the data into fixed intervals. Equal frequency binning ensures equal size groups. Thank you for watching. If you have any questions, feel free to ask in the comments. Your feedback is always appreciated.